Okay, in this video we're going to take a look at an ideal gas law problem. Obviously I'm telling you it's the ideal gas law at the top of the page, but you won't always get that information, perhaps on a quiz or on a test or on your final exam. So I'm going to show you how to read just the problem and figure out that this is indeed an ideal gas law question. You need to use the ideal gas law. Okay, the problem says, what volume? I'm going to go ahead and box that in and label volume as my unknown. It's asking me to find volume. And then it says, will 5.0 moles. This is a key word right here. Anytime you see the word moles in any of these any gas law problems, you know immediately you're going to have to use the ideal gas law. Why? Because it's the only one that lets you calculate moles. Okay, then it says moles of nitrogen will occupy at 2 atmospheres. I'm going to label this as pressure. How do I know it's pressure? Because atmospheres is a unit of pressure. And then I can label 25 degrees Celsius as my temperature. How do I know that's temperature? The unit degrees Celsius lets me know that's the temperature. So because I see this key word here, moles, I immediately know I'm going to have to use the ideal gas law. PV equals nRT. P is pressure, V is volume, N is number of moles, R is the gas law constant, I'll show you in a second, and T is temperature. From here, it's just kind of a simple plug and chug situation. What did I label as pressure? Well, I labeled that as 2 atmospheres. My volume I labeled as unknown. Number of moles we labeled as 5. R. R is a gas law constant. It's always the same number, 0.0821, and it has some kind of scary units. It's liters times atmosphere divided by mole times Kelvin. I know that looks scary, but if you just take it as this is a number, this is a unit, this whole thing together is a unit, it's not so bad. Okay, and then my temperature. Please do not make my favorite mistake. If you accidentally put 25 degrees Celsius in there, please cross it out with a big fat X. You must convert to Kelvin. So I'm going to add 273 and plug in 298 Kelvin for my temperature there. So that's where I got my temperature. Okay, my units are going to cancel. Atmospheres will cancel, moles will cancel, Kelvin will cancel, and I am left with liters for my unit of volume, which makes sense. I'm solving for the volume variable. Okay, now how do I solve this? This takes a little bit of algebra, and I know my students sometimes don't care for it. How do I isolate the variable V and get it all on its own? I'm going to have to divide both sides by 2 atmospheres to cancel out 2 atmospheres on the left. Whatever I do to one side, I have to do to the other. So to solve this, punch in your calculator 5 times 0.0821 times 298 divided by 2. You should get, for a final answer, that your volume is equal to about 61.2. Depending on where you round, you might get something slightly different, but I got around 61.2 liters. This has been a Rodriguez original production. I hope you enjoyed it. Go back, rewatch it, try other practice examples, study, study, study. Good luck.